Hey everybody, I just wanted to spend a little time talking about other types of radioactive decay, or other types of radioactivity. Um, and so there's really only two others that I really want to talk about. Now, that's not how many we're limited to. There's a plethora of different types of these things, but two of the more common of these is something called positron emission. Okay, and during positron emission, okay, a positron here. Let me make sure that I have a positron is an anti-electron. Okay, it is the anti-version of an electron. So it has the same mass but opposite charge as an electron. Okay, that's why its symbol is the beta, but instead of having a -1, it has a +1. Okay, and we have seen that certain heavy elements will give off positrons as opposed to electrons, or opposed to gamma radiation, or whatever. Okay, and so, excuse me. Okay, so here we have an example of polonium that is emitting a positron. Now, this word, emission, tells us which side of the reaction the positron is found in. Okay, in this case, it's found on the product side because the reaction is emitting a positron. Okay, and so by emitting a positron, all the rules of balancing stay the same. The mass number, the atomic number, these have to add up. So this is a positron, +1 plus 83 is equal to 84 here. This is 84, and then this has to add up to 207 on each side, and it does. Okay, so positron emission is kind of neat. Okay, and now electron capture is another thing that happens. Now, this is not ionization. Okay, let me just say that this is not ionizing. Okay, it's important to know this. We're talking about nuclear chem. So this is an instance where an electron falls into the nucleus and causes a nuclear reaction. Okay, and so it's important to understand that we're not just talking about an electron getting trapped and then orbiting around the nucleus. This is a nuclear reaction where the electron actually will go into the nucleus and cause something to occur. Okay, and the word capture tells us that the reaction has the electron on the reactant's side. Okay, and that we are capturing an electron. The electron is not being produced, rather it's being reacted away. It's capturing the electron. Okay, and so we see these electron capture reactions with some of the lighter elements like beryllium. Okay, and so again, same rules apply with balancing. We want to make sure that the reactants and products all add up using atomic number. So 4 plus a -1 is 3. And that equals 3. And then 7 plus 0 for the atomic mass. 7 plus 0 equals 7. Okay, so that's all balanced. Okay, so these are two other types of radioactive decay. And again, like I said, there's a bajillion other types. There's neutrinos given off. There's antineutrinos. There's, let's see. What are some of the other types that I know? There's neutron capture, neutron decay. I don't know. The list is endless. So we're just going to stick to these two other types. Okay? So have fun with that. See you later.